And listen, I hope you guys get this. I am so pulling for y'all like hundreds. I just don't see a good reason why we can't do something like that, right? Anyways, Joe, your question.
Yeah, can you remind me of the day that the concert we tried to do?
Say that one more time.
Can you remind me of the day that the concert we tried to do?
Oh, like the last day?
Yeah.
February 6th. I left that up there because I was going to forget if I didn't leave it up there. Yeah, February 6th. Any questions on these DMR questions? All right, fair enough. So, guys, hey, listen, please. Listen up. So I did want to kind of piggyback off what Joe just asked. There have been a pretty healthy number of people that have done quiz retries, and that's great. I hope that you are checking your grade book to see how those went. Basically, the plot is this. It's pretty simple. In order for you to bump your score up to that 95, which I know that's we're shooting for that, right? The goal is to get up to that A category. You have to get all of them right? You got to get them all right, because 95 means you pretty much have this thing mastered, not you were close or almost or whatever. It means you got this thing nailed down solid. You're a master of it. So I'm okay. I'm okay if you end up having to do a retry 2, 3, 4, 5, 6. Please don't let it be 50 times, right? I'm okay if you got to try a bunch of times. Josh, please stop. Ben, please stop. I'm okay if you got to try a bunch of times. Just please do it. So there are definitely a handful of folks that on some quiz or whatever from the recent past, some concept quiz, have like a 0 or a 50 and haven't like said a word to me about doing a retry. To me, that is unacceptable, right? You should look at that 0, you should look at that 50 and just think, oh my goodness, I need to do something about that. I've reminded you every day now for almost a week. Let's do retries. The due date is the 6th and all this stuff. And a lot of people have responded well, and that's great. There's a handful of folks that maybe you're too busy or you forget. I don't know what it is, but I definitely am going to strive to talk to you personally about that. Just know that I see that, and I'm not okay with it, and I don't think you should be either. I don't think you should be okay with a 65 either. I mean, if you try and the deadline comes and goes, I mean, like, I'm going to work with you. Like, you'll come in and we'll get this thing figured out. Like, I just don't think there's any way around the idea that you have a great chance of getting a 95 on all those concept quizzes. That's my hope. It really is. So please do consider if this week kind of comes and goes and we still got folks hanging out in the 0s and the 50s, you'll get pretty hard sell from me early next week on you better get in here and all that good stuff. Just know it's coming from a place of caring. I want you to understand. I want you to learn. I want you to get it and feel good about what you're doing. And it's all positive things. It really is. So, okay. Any questions about any of that? Okay, cool. So we're gonna do this whole negative exponent thing here real quick. But I thought I'm gonna give myself a bit more room here. I thought it would be a great idea for us to see how you guys are doing with retaining the stuff we've worked on the last couple of days. So if you would, grab some real estate on the big boards or grab a small board and a marker, up to you. And I thought we'd do 1 or 2 practices.
You didn't see that, Ben. Dang it. I said Autobots roll out and literally roll. I was like literally like, Autobots roll out. It's time to stop.
Okay, it's so easy.
Hi. Say again? Of course. All right, ready to go. Please try that one.
We didn't learn that. No, 6 that's serious.
Once you think you got it, just let me know and we'll see how it went.
For a second, I thought that for the straight line thing, but I forget what it was called.
All the absolute values?
Yeah, as well.
They're kind of straight looking parentheses, I'd say. Hey guys, once you start to get them, if I'm not around you, feel free to look at your friends, see if you all agree. discuss if needed.
Do it with me.
Take
Do it like
the chase. That's great. Nice work.
Did you not see my Autobots roll out?
Please look at what's going on around you. See if you agree or disagree.
You know what? Get out of here.
There you go.
No one likes you.
See that Whit got it right. I don't know. Did you guys get it right?
Yes, they did.
How do you know? You all got the same thing.
We got the same thing as he did.
Okay, there are some differences up here, for sure. So, for instance, Aiden, you actually got that wrong. Did you see that? Yes. You wrote 25x to the 8 over 6y to the 10. That would be incorrect. Callie, you had it wrong for a little while. Did you fix it? You had 36 over there somewhere, right? Yeah.
Because I'm not thinking. Kelly, real fast.
Okay, here's the answer. 25x to the 8 over 9y to the 12. You guys doing okay?
Tomorrow. I'm doing it tomorrow.
There we go.
I need to print out like the sheets that I need to bring in tonight. Yeah, neither do I. So I'm just gonna print them off at my house, and I can come in just at the beginning of it and give one to you. Let's redo it. Where are you from? Same places. You have to go and you don't have to redo that. I think once you have one, redo assignment, you can just keep doing it. But I don't think you need like to print another one. It's like read.
I love Grace.
All right, there is your second one. Ready, go.
Why are you talking about Grace? Grace tells us like it's gonna be Wednesday. Oh, I can totally see that. And Carson. It's gonna be Grace that'll be so cute. No, it won't be cute.
What?
I want that role.
You got a witchcraft.
I know, she was.
You added
She was Lucas. I want to be Morticia. Like, I wish that they were doing a song that involves Morticia because
Kill me now.
I really do. But it definitely would be.
So what do we do now?
I could do Morticia.
16 times 8.
What is this?
You forgot the left side.
Don't you see me as where did that come question? Mr. Anderson? Can you subtract even when there's a base?
Oh, like the
How do
8?
you go from here?
Yeah, because all this is really 8 times this. And so these can be dealt with on their own.
So, what is that?
Once you think you got it, let me know and we'll check your answer. I think that's right. Good job. Well done.
So that's not division, that's subtraction. That's 8x to the 18.
If you're dividing bases, you subtract your exponents. That would be correct. What is that?
Oh, sorry, that's a
Got it.
Yep, looks good.
Thank you.
Where'd you get one?
This is correct?
Yep.
Yep.
Connected. That's just one thing.
Is it?
It's like totally two.
You can simplify that.
You can.
What's
but
8
I
times
thought that-
16? They're all
But I thought
times.
that those were like connect. Like this entire thing was connected.
By multiplication. You're right. So it's 8 times this times this times this times this. Okay, what you got? Nice work.
Only violence and love is I'm just gonna take all the time.
Okay, we got some interesting stuff. Hey guys, hey, listen up please. Let's all look at this.
You connecting
This step is real good. That step is real good. Where did the 7 come from? So here's the thing. Here's where a fundamental thing we got to make sure we understand. There's a difference between a base and an exponent. So this 8 is a base, right? And this 1 down here that you were thinking about is a base. What is 8 divided by 1? It's not 7. It's 8, right? Where you end up subtracting here is if you have a base with an exponent divided by the same base with an exponent, that's when you subtract not your bases, but your exponents. So you did that nicely right here. This was well done. This should still be an 8 because 8 divided by 1 is 8. But then this can be simplified. This should be an 8 times this times this times this. Well, 8 times 16, you can simplify that. X to the 18 times X to the 6, you can simplify that. Does that make sense?
Yeah.
Make sense? So keep going with that. Simplify it all the way through. It's not a plus. That looks like a plus. Make sure, Jaden. It was, oh, sorry, it was times to begin with. It's still times. Yep, leave it as is. Okay, here's your answer. Any questions?
Yeah, I'm just kind of confused, like on, like.
Yeah, you're mixing up your rules big time.
Yeah.
So, 2 to the 3 is 8. I agree with that. X to the 8 to the 3 is not X to the 11th, and here's why. Cubed, doesn't cubed mean times itself 3 times?
Yeah.
So, X to the 8 cubed, just look right here. Wouldn't this be X to the 8 times X to the 8 times X to the 8? If you got 8 x's times 8 x's times 8 x's, how many x's are being multiplied together?
24.
Yeah, so actually when you have this, you actually multiply your exponents.
Oh, okay.
So you want to, I think it's really important that you understand the why, because I've seen way too many students like you who have like this real surface level understanding of like, sometimes I add my exponents and sometimes I multiply my exponents, but I don't know when I do which one.
Yeah.
If you understand to this level, then you can always, if you do get confused, you can always break it down and say, well, cubed, that just means this times this times this. There's not 11 of them. There's 24 of them, right?
Yeah.
And so you'd multiply those exponents.
Okay.
Same thing down here, right? X to the 2 to the 3, that means x squared times x squared times x squared, that's 6 of them. So it should be x to the 6th.
So I do that for the same one here,
Same
right?
thing, yep.
Okay.
So I want you to, I really, really want you to understand the rule and why it works, not just memorization of it,
Yeah.
right? Because for most folks, that never works. You forget it, you mix it up. So. Hey
Okay.
guys, take a seat, please. Make sense?
Yeah.
Okay, cool.
Thank you.
This letter, and he'd say, it's a D. And then he'd say, Daddy, why is that a D? And my response is kind of like yours. That's just what it is. We've all agreed that that thing means D, and it sounds like duh, right? Right? And so what I'm about to show you is on that level of this is what this means. Like, there is, like, if we ask the question, why is that a B? There might be some historical reason, but there's not going to be like a really great reason for why that's a B. The same thing here. Is there, there is a story behind the reason why the 3 is a 3, but at this point in your life, aren't you just going to say, it's a 3? We've all agreed that that's a 3, and we don't really need to argue about why it's a 3, right? So, what I want to show you here this afternoon is something similar to that. This needs to be something that we all just agree, this is what this means. Does that make sense? This is what this means. So we're going to be looking, first of all, at negative exponents. And we'll look at something a little bit different at the end. We'll do some examples in between. So here we go. Negative exponents. The other day, I think it might have been the other class, maybe it was this one, somebody said, you can't have negative exponents. They were thinking about how you would subtract or whatever. You definitely can have negative exponents, and they do have a meaning. So the meaning of a negative exponent is this. Flip the base to the other level. This should be Unit 5, Day, what is it, 3?
I was looking at the 0 exponent.
Gotcha, we'll get there next. So, meaning of a negative exponent means you need to take the base and flip it to the other level. And when I say other level, I'm talking about we either need to flip it to the numerator or we need to flip it to the denominator.
Whoa.
Denominator. You guys know what I'm talking about. So meaning of a negative exponent means wherever that base is, you need to flip it to the other level. If you got a negative exponent on a base and the base is in the numerator, flip it down. If it's in the denominator, flip it up to the top. That's all it means. So if I saw something like x to the negative 3, we're going to look at that and recognize that right now currently is in the numerator, right? It's over 1. And so that negative exponent means flip to the other level. And so since the base, the x, is in the numerator right now, flipping it to the other level would mean flip it down. Does that make sense? So this would end up going denominator of x to the positive 3. I would have an empty numerator at this point. Whenever I've got an empty numerator or an empty denominator, what number do we put there? It's a 1. Yeah, whenever you've got an empty numerator or an empty denominator, either one, you can always fill it with a 1. Now, the next example is sort of similar. 1 over x to the negative 5. You can obviously see the negative exponent on the base of x there. So that means the base needs to flip to the other level. Well, right now the base is in the denominator, so it needs to move up to the numerator. So this would become x to the positive 5. And if you wanted to still have a denominator, it would be over 1, because now the denominator is empty. Or you could just, of course, leave it as x to the 5th. Notice that when I flip the base to wherever it's supposed to go, notice the exponent becomes positive. The reason for that is I did what the negative told me to do. Right? So it doesn't need to be there anymore. I flipped it up to the other level, or I flipped it down to the other level. And so I've got some examples, granted a little more complicated than what we just did, and I just want to see what you can do with these. So if you would, please try number 1. Using the definition of what a negative exponent means, we all just agreed. A negative exponent means this. It means to flip it to the other level. So please try number 1. So I would ask you, like if you did that, I would ask you, does the x have a negative exponent? So it needs to flip, right? Does the y have a negative exponent? So it stays. So just go factor by factor.
Thank you.
You bet. That's a good question. Okay, we're going through and we are simplifying this, doing what the negative exponents are telling us to do. Okay, so I'm going to ask you a series of questions. And the way you think about these questions will really help you, hopefully, get these simplified in a correct way. So I'm looking at number 1, the x. Does the x have a positive exponent or a negative exponent? So that means it needs to go, right? It needs to flip. So I'm going to write that as x to the 4th in the denominator, right? It was in the numerator. Now it goes to the denominator. The y. Does the y have a positive exponent or a negative exponent? So it stays right where it is. Stays in the numerator. The z. Does the z have a positive or negative exponent? So it needs to go. It needs to flip, right? Jaden, you with me? Okay. So you'd end up with this as your final expression. Notice how the x flipped down and the z flipped up to the top, but the y stayed where it is because the y had a positive exponent to begin with. The other two had negative exponents, so they go. What people will want to do often is they'll want to look at the numerator and flip the whole thing. The y's got a positive exponent, so it needs to stay right where it is. Okay.
Just like the final answer?
That's it. We've simplified it now. We've moved it from having negative exponents to positive exponents. And later on, I might ask you to make all the exponents negative. I just want you to be able to understand how they work and what they mean. Yeah. Question, Kyrie? No. Anybody have a question on that one? Okay, then. Why don't you guys look at number 2. Try to do the same thing. Simplify dealing with negative exponents. Number 2. Okay, guys, hey, some of you think you have it and you don't. So number 2, I will start this time in the denominator, just to be different. So the y to the 3rd has what kind of exponent? Positive or negative? Positive. So it stays. What's the exponent on the 5? Positive what? 1. So it stays. What's the exponent on the z? Positive 9, so it stays. What's the exponent on the x? Negative 2, so it goes, right? It needs to flip down. What's the exponent on the 8?
It's a positive.
Positive 1, so it stays.
Crazy, man.
So what people tend to think is that the 8 and the x to the negative 2 are somehow inextricably attached to each other, where if the x goes, the 8 goes with it. The truth is, the way that the 8 and the x are attached to each other is no different than how the x and the z are attached to each other. My friends, it's all multiplication, right? And so if the x can drop down to the denominator and the z stays there at the top, the 8 could be doing the same sort of thing. And so this would be your final simplification. The vast majority of people that I saw that made a mistake brought the 8 right on down there with the x. The 8 really needs to stay. Go ahead.
Would it be 8 z to the 9 or just like or 8 in that space?
What symbol is going on right there? It's multiplication. So if you wanted to put 8 dot z to the 9th, no problem. The space is a little larger than we typically have, but it's still just times. Yeah. Okay. So I know that was a little bit shocking. Do you have any questions there? All right, lovely. We'll get a chance to practice this a ton tomorrow, maybe a little bit more today. If you guys would, flip ahead. A little bit more to be done here. Here we go. So we just got done looking at what a negative exponent means. A negative exponent means to take the base and flip it, either up or down, depending on where it is. Okay? Zero exponent. Whew. This one can be a challenge sometimes too. So the meaning of a zero exponent is this. Let's develop this first. Let's simplify this in two ways. I've got x to the 5th over x to the 5th. Let's do this with just regular old division. Let's think of it like this. If I have x to the 5th over x to the 5th, couldn't you say that that's just something divided by itself?
Yes.
And if you divide something by itself, what do you always get? Okay.
Wouldn't it just be x?
No, if I have any, with one exception, which you can see we're going to talk about, with one exception, if I take any real number and I divide it by itself, I get 1. Right? So you got x to the 5th over x to the 5th. Like if I said x was 9, I'd get 9 to the 5th over 9 to the 5th, which is 1. If I said x was negative 3, I'd get negative 3 to the 5th over negative 3 to the 5th, also 1. Like I said, there is an exception to that, which we'll get to in a second, but I think we could confidently say, absent that exception, we're always going to get 1 here, aren't we? What about exponent properties? If I am dividing like bases, what do I do with my exponents? Subtract them. Okay. So what's 5 minus 5?
0.
So we arrive at this thing that we were just talking about, x to the 0. So based on what you see presented to you, what would you guess x to the 0 is?
0.
Self. No, it's 1.
Think about what I did. I started off with this.
It's non-existent.
I started off with this x to the 5 over x to the 5. I came over here and I found out that the answer is 1. And then I did it a little bit of a different way. I used an exponent property that we know to be true, I think, and I got x to the 0. So what does that mean for x to the 0?
It has to be 1.
It has to be 1. X to the 0 is 1. So I know, but see, this is actually sort of a mini proof of that. We could do division to get to a simplified answer, or we could get over here and kind of get stuck and say, well, gee, what's x to the 0? Well, we could just do division over here and see, well, I got 1, so x to the 0 must be 1. So I mentioned that therefore anything to the 0 is 1. Anything to the 0 power is 1. Can anyone think of the one exception to this property? There is one. One number that just doesn't work.
0?
Say again?
As if it's divided by 0?
So maybe rephrase.
It's being divided by 0?
What's being divided by 0? Let me rephrase a little bit. what is the one exception to this property? The exception would be if x equals 0. Right? Because if x equals 0, wouldn't you get 0 to the 5th over 0 to the 5th? And you can't divide by 0. Right? You can't have a 0 in the denominator. It just makes no sense. So that's the exception, right? So anything to the 0 is 1, except 0 to the 0. And we would just say that that's indeterminate or undefined. It's not a real number. Okay? So anything to the 0 is 1, with the exception being 0 to the 0. Okay. So this is actually a pretty decent proof. And you might be sitting there thinking, what? That doesn't make any sense. Think through this process right here. We're all familiar with anything divided by itself is 1. And I think we're getting familiar with subtracting exponents in these cases. And you can see if this really is 1, if this really is x to the 0, they would have to be the same thing. Hopefully that seems logical to you. So you're going to get a chance to practice this. Word of caution on these, be careful. Okay? It's all attainable. Just be careful with them, all right? Ready, set, go. Here's your practice with these. 3 of them. See if you can simplify. Is number 1. What is the exponent on the 5? The exponent on the 5 is a 1. So it's just going to be 5 to the 1st, or just a 5. What's the exponent on the x?
0.
And as long as x isn't 0, x to the 0 is? 1. So times 1, and y to the 7th is just y to the 7th. This should give us a final expression of 5y to the 7th. So it's tempting here to look at this and just say, oh my gosh, the answer is just 1. The whole thing wasn't to the 0. It was just the x only. Number 2. What's the exponent on the 3?
1.
What's the exponent on the x?
5.
What's the exponent on the y? But that entire expression is to the 0. And remember, anything to the 0 is 1. So this whole thing would just end up being a 1. Does that make sense? Anything to the 0, including 3x to the 5th y to the 8th. Whatever it is, if it's to the 0, you're going to get 1, as long as it's not 0 to the 0. How about number 3? What do you guys think the answer is for number 3? Yep, it's simply a 1. It's the whole thing is being taken to the 0 power. You would get a 1. Again, assuming that neither x nor y is 0, that's what you'd get. Yeah.
So pretty much like anything in parentheses to the 0 is just going to be 1.
Be careful.
Unless it's to the 0.
You could be fooled. Watch this.
Oh.
So it's going to be 5 times 1. So people want to overuse this rule and just say, oh my gosh, I saw a 0 exponent, therefore the whole thing's just a 1. If whatever the base is, sure, that to the 0 is 1, but there could be other stuff in there. Yeah. Yep, good question. Okay, let's get ready for your quiz. I think the timing's going to work out really well on this, so get your tables rearranged and we'll get started in just a second.